projects. In this video, we are going to explain about a project titled An Enhanced Multi-Modal Biometric Authentication. Now coming to the introduction part, the Python implementation of the system ensures easy integration and deployment across various platforms and devices. The user-friendly interface and well-documented code base make it accessible for developers and businesses seeking to enhance their security infrastructure. The enhanced multi-modal biometric authentication represents a significant step forward in the realm of biometric authentication system. By fusing multiple biometric traits, leveraging machine learning algorithms, and emphasizing data security, this project offers a comprehensive and efficient solution to meet the ever-increasing demands for secure user identification and verification. By incorporating multiple biometric traits, the system can adapt to different scenarios, providing efficient and reliable identification in diverse environments. Whether it's in access control, mobile authentication, or financial transactions, this enhanced multi-modal biometric system offers a robust and scalable solution. So our main objective for this project aims to offer a user-friendly and accessible solution. The Python implementation ensures ease of integration into existing systems and allows for effortless deployment across various platforms and devices. The well-documented code-based facilities collaboration among developers, enabling them to customize and extend the system to suit specific requirements. Ultimately, the enhanced multi-modal biometric authentication seeks to push the boundaries of biometric authentication systems, elevating the standard of security measures and setting a new benchmark for accuracy and reliability in user identification. With the use of advanced encryption methods and data anonymization techniques, the system aims to safeguard sensitive biometric information, protecting user identifiers from potential threats and unauthorized access. Coming to the requirements part, there are two types of requirements, that are hardware requirements and software requirements. In hardware requirements, operating system, that is Windows, is required. Processor i5 and above. Minimum 4 GB of RAM is required. Hard disk 20 GB and above. Coming to the software requirement part, Python IDEL, that is 3.7 version, is required. Now coming to the methodology part, first, upload multi-modal dataset. The first step in the enhanced multi-modal biometric Python project involves uploading a diverse and comprehensive dataset that includes multiple biometric modalities. This dataset will consist of biometric samples such as fingerprints, facial images, iris scan, voice recordings, or any other relevant biometric data. Second, pre-process and KLDA features extraction. Once the dataset is uploaded, the next phase involves pre-processing the data to ensure consistency and readiness for training. Pre-processing steps may include normalization, resizing, noise removal, and data augmentation techniques. After pre-processing, the project may utilize the kernel discriminant analysis, that is KLDA technique, to extract discriminative features from the multimodal data. It helps in reducing dimensionality while maximizing the separability between classes, enhancing the model's ability to differentiate between different individual securities. Third, train deep learning multi-modal model. With the pre-processed and feature extracted data, the project proceeds to train a deep learning multi-modal model. This model will incorporate multiple neural network architectures, each designed to process a specific biometric modality. The deep learning model will learn to extract relevant patterns and representations from the biometric data, effectively capturing the unique features of each modality and combining them for enhanced authentication. Fourth, training accuracy graph. During the training process, it is essential to monitor the model's performance to ensure it is learning effectively and not overfitting to the training data. A training accuracy graph is used to visualize the model's accuracy on the training dataset over successive epochs. This graph helps in understanding the convergence of the model and allows developers to fine-tune hyperparameters or identify potential issues if the accuracy fluctuates. Fifth, authentication from multimodal images. Once a deep learning model is trained and validated, it is ready for use in the actual authentication process. This step involves taking multimodal biometric images or samples from users and passing them through the training model. The model then pre-processes the data, extracting relevant features and making a decision about the identity of the user based on the combined multimodal information. 6. Exit. The exit phase refers to the conclusion or completion of the enhanced multimodal biometric Python project. At this stage, the project's objectives have been achieved and the system is fully functional or multimodal biometric authentication. This phase may also involve documenting the process of the project results, creating users' guides, and preparing the system for deployment in real-world applications. So now to execute the project. For executing the project, first we need to open the code folder. So here you can see we have a folder named as dataset. In this we are containing some folders named as ear, face, fingerprint, iris and palm. So here in these folders we have some of the images of ear, face, fingerprint, iris and palm. In this folder features we have some text files. And in this folder model we have .hy files which contain the deep learning algorithms information. These .hy files can be loaded into the project code during runtime to utilize the trained model for various tasks such as making predictions on new data or performing specific operations. Here this folder test images containing some sample images in this for testing it. And the files face, finger, multimodal, train, these are the Python files which are containing the Python scripts in it. Here face finger is the main Python file here. And this is the run.bat file. Instead of executing the program in command line interface, we created Windows bat file to execute the project. Now to run the project, double click on run.bat file to execute the project. So here this is the graphical user interface. With this we are interacting with the program. Now click on upload multimodal dataset button to upload the dataset for getting the output. Here I am selecting dataset folder. Now click on select folder button to load dataset for getting the output. Here on this screen dataset uploaded. Now click on pre-process and KLDA features extraction button to read all images and then extract features and then split dataset into train and test where application use 80% of images for testing and 20% for testing. Here you can see 600 images processed and then split dataset into train and test. Now click on train deep learning multimodal model button to train model for getting the output. Here on this screen you can see that we got model accuracy as 0.98. Now click on training accuracy graph button to get the output. Here on this graph you can see that x-axis represents epoch number whereas y-axis represents accuracy and loss value. And here green line represents accuracy and yellow line represents loss value. And we can see each increasing epoch accuracy got increased and loss got decreased. Now closing this graph, click on authentication from multimodal images button to upload folder with face, fingers, iris, palm and ear for getting the output. Here I am selecting sample1 folder. Now click on select folder button to load test images for getting the output. Here on this screen you can see uploaded multimodal images are authenticated as person ID 4 and similarly you can upload other images and test. And try with some another image. So by clicking on exit we can exit with this project. And now coming back to the conclusion part, conclusion. In conclusion, the enhanced multimodal biometric Python project is a significant step forward in the realm of biometric authentication systems, showcasing the capabilities of modern technology to safeguard user identities and data while providing a seamless and dependable user experience. With its groundbreaking approach, the project has the potential to revolutionize the way we approach security and authentication, contributing to a safer and more trustworthy digital world. Furthermore, The Python implementation of this project contributes to its accessibility and ease of integration. The user-friendly interface and well-documented code base enables developers and businesses to seamlessly incorporate the system into their existing infrastructure, fostering wider adoption and application across various industries.
For updates on latest project videos, please visit True Project's YouTube channel and subscribe.